So good afternoon, everyone, or good morning, depending on where you are, or even good evening. I know we have some people also from UK joining us today. Welcome to our first workshop. As you know from the email invitation, so we are working on a project, River Morphology Information System, RIMORPHIS, and this is our first workshop. And so thank you for attending. So as you know, the goal of this workshop is community building and partnership. So specific objectives of this workshop, we want to inform you what we are doing for RIMORPHIS, so design and development of the platform. We are also interested in seeking partnerships. So we hope to share a lot of data and tools on our platform. So we are seeking partnerships for sharing some of these things. Then we also want to survey you and know what you expect from us. And we would also like to get some feedback on some of the functions and operational features that we are developing. All of you must have gotten an email with an invitation to complete a pre-workshop survey. And I know some of you have already completed this survey. If you have not completed this survey, here is a link, and we will also post this link in the chat box. So we really would like to get your feedback on some of the questions that we are asking for the workshop. This is our agenda for today. So it's a tight agenda, but the goal here is to mostly inform you what we are doing. We have also lined up some invited presentations, lightning talks. So these are again from our potential partners. So we think that some of the data and tools and what they do will benefit us. So here is a list of presentations that we are going to have from 2:10 to 3 p.m. Eastern. And the first hour is going to be the project team talking about our project. So what RIMORPHIS is, what the cyber infrastructure behind that is, and some of the use cases. So we are going to meet today for 3 hours, 1 to 4 p.m. Eastern. And then we will meet again next week on May 19th. So we will meet for 2 hours next week, so from 1 to 3 p.m. So this will be follow-up of what we present, what we hear from you, and where we go from here. This is a list of all the participants that I had until yesterday. So I know some people have also registered since this list was prepared. So if you don't see your name, we will include your name eventually, and we will share this list with all of you. So when we prepared this list, we had 49 attendees from 23 institutions, so 11 national and state agencies and 12 academic institutions. This list is organized in alphabetical order with last name. So if you invited someone or you recommended somebody's name, hopefully you will see their name on this list. And I realized I forgot to even introduce myself. So this is a time. So I'm Venkatesh Mirwade. I'm faculty in the Lyle School of Civil Engineering at Purdue University. This is a collaborative project. So I'm the lead PI, overall lead PI on the project, and also lead PI from Purdue. We have, so I think all investigators are in panelists roles. So I would ask them to maybe introduce themselves instead of me telling who they are. So if you don't mind, Amanda, do you want to go next?
Sure, yes. Good afternoon, I'm Amanda Cox. I'm at St. Louis University. I'm the director of our newly formed Water Institute here, and I'm also an associate professor of civil engineering. Ibrahim, I'll let you go next. Thanks.
Yes. Hi, this is Ibrahim Demir. I'm a faculty member at the Civil and Environmental Engineering at the University of Iowa, also the director of the Hydroinformatics Lab. Toby?
Yeah, hi, I'm Toby Minear. I'm a research scientist at the Cooperative Institute for Research in Environmental Sciences at the University of Colorado Boulder. And yeah, I work mostly on remote sensing and surface water.
I'm Marian Masti at IHR Hydroscience and Engineering, University of Iowa, with expertise in river hydraulics, experimentation, and hydroinformatics.
Yeah, I'm Shayan Dey. I am a graduate student working with Professor Mewade at Purdue University, and my research mostly focuses on the role of river bathymetry in flood simulations.
So I think Changyang, Ho Junyu, and Yusuf, they are not here, or at least they don't have the panelist role, so we will not be able to hear them. So these are the students and postdocs we have that are working on this project. So we would like to have your active participation. We decided to do the workshop in webinar mode, so we don't have to worry about all the background noise and having difficulty listening. So, but you please interact. So there are multiple ways by which we would like to hear from you. One is you can simply chat your questions or comments in the chat window. We also have, if you want to speak, instead of just typing your questions, please raise your hand, and I understand there is a way that we can enable your microphone or unmute you so you can talk. We also have a live Google Doc, and there is a link here, and this link will also be posted in the chat box. So if you want to directly type your comments, questions, whatever you want to tell us, please feel to do that in that Google Doc also. So there are multiple ways by which you can provide feedback. As I mentioned, we have lightning talks. So right now, all of you are in attendee mode, which means we cannot hear you, but we will make all the lightning talk speakers as panelists or presenter during that session. So we want to see and hear you, so you should be able to do that. And we are going to run all the PowerPoints from our end. So we have created a master document of all lightning talks. So we will just run through that master PowerPoint presentation, and we will let you talk during your time. Since we are going to join you as panelists during that session, please make sure that we see your name, that we know. I know my daughter uses my laptop, and sometimes when I join meeting, the name I have is Hamster Bunny or something like that. So I hope we will be able to see your name so we can promote you as a panelist or presenter during the lightning talk session. So these are just some of the housekeeping things that I wanted to do before we get started. So before we get started with the first presentation, if you have any questions, please feel free to type them in the chat box or raise your hand. I'll just pause here for maybe 15-20 seconds. And in the meantime, I will change my slides and we'll start with the first presentation. So I'll stop share and start again. So I hope you are able to see my screen. Maybe Ibrahim, you can give me a thumbs up if you're seeing my screen. Okay, thank you. So what I would like to do now is I would just like to give you a brief overview of our project. So as I mentioned, the official name of this project is a little different when we submitted the proposal, but we changed the name, and I will give you a history about that briefly. So we are calling our project as RIMORPHIS, which is an acronym for River Morphology Information System. So again, I will be giving this presentation, and I'm Venkatesh Mewade from Purdue. Before we get into river morphology, we just wanted to describe what we mean, our project team mean by river morphology. I think different people have different meaning and interpretation of what river morphology is. So for us, it's basically shape and composition of river channels that change with space and time. And in terms of spatial extent, we are mainly looking at the river and its corridor, the floodplain. We are not going much beyond that. So that's our scope in terms of what we think of what river morphology is. And since we are going to be dealing with data and tools, so the key data sets that we are interested in serving, storing, and providing to our users are river center lines, bank lines, river bathymetry. So river bathymetry could mean surveyed points from single beam, multi-beam. This could be surveyed cross sections and so on. We also want to include information on bed and bank material composition. So this is our sort of scope when we think of river morphology for RIMORPHIS. Why we need river morphology data? So we use river morphology data in many applications for research and operations and management of rivers. So when we do hydrodynamic modeling, we want to describe the river geometry, and that river geometry includes center line, bank lines, cross sections, and bathymetry, depending on whether you're doing one-dimensional or two-dimensional hydrodynamic modeling. We also need information on sediment for sediment transport, morphodynamics, how the river bed is changing over space and time. So when you want to do that kind of analysis, you need river morphology data. Nutrient transport. So again, if we are looking at interaction between river and floodplain and how these things are interacting in terms of nutrients. So even to do that, we need hydrodynamic data and floodplain data, and that again will come from RIMORPHIS. We want to map and understand river ecohabitat. So again, to do that, you need river morphology data. And as I mentioned, for management of river resources and river infrastructure. And I was looking at some of the feedback that we got from the survey. So many of you also mentioned about bridges and culverts. So that again becomes part of the river infrastructure that is mentioned here. So as you can see, we need river morphology data to do all these things. The question then is, can we get the data that we want? And what I want to discuss on this slide is what the current status is. So our current status is we have issues getting river morphology data. So the first issue that we have is accessibility. So we know that some data exists, but these data sets are not publicly available. These are collected by individual researchers and agencies, and they are stored in different places. So it is difficult to access some of the useful and good data that we know exists, but we cannot get it. The second issue that we have is availability. So availability, what we mean by availability is that we collect data, but these data are expensive to collect. So these get collected for very small reaches, or even within a reach, very small segment of that reach. So we have data on river bathymetry, sediment, and hydrodynamics that are collected for very small areas or reaches. So if I'm interested in doing something over a large scale, I don't have data to do that. So what can we do if we want to make data available over large areas? So that is also an issue. The third issue that we see is interoperability, and interoperability has to do with formats. So in some cases we have data that we can easily use. In many cases we have data that we cannot really use unless we spend a lot of time reformatting, processing that data, and get it in a form that we can use. So again, just to give you an example, if you want to think of cross sections, so if I'm creating a 1D HEC-RAS model, I want cross sections as 3D lines, but many times we have these data available as points, so we don't have tools to go from points to lines. Sometimes we have to extract these cross sections from digital elevation models, and we don't have tools easily that can extract this information and get it us easily into the model that we want to use. Usability. So again, if you want to use that data, you need tools. Now, tools for analyzing some of these data sets are scattered and they are not easily available for public use. Many of these are proprietary and also platform dependent. So most of these tools work on Windows, they may not work on Linux or Unix environment that you may be using. So these are the issues that we have with river morphology data. And we want to provide solutions to those. So in terms of accessibility, we want to provide easy access to river morphology data at multiple scales in one location. So can we have a one-stop shop for river morphology data that will provide access to all these data sets that are not very easy to access? So this is why we are having this workshop. So if your agency is collecting data, we would like to provide an entry point to those data sets through our platform. Availability, as I mentioned, we may be getting data from some of you and they may be scattered and they may be available for very small areas. So we want to complement some of these data sets with other resources so we can provide data over larger regions or over a stream network. Interoperability, so I spoke about formatting issues, so we want to have some pre and post processing of these data sets, so we want to have tools that can do that so you can use the data in the form that you want. And finally, in terms of usability, we want to again have tools and resources that will enable use of this data for research and applications. Now, so this is what we want to do, and we have been in some way we have been trying to address some of these issues for a long time. So what I'm showing you here is some of the work that I have been doing, and you can see the first tool that I list here, RCMM, which stands for River Channel Morphology Model. This was part of my PhD at University of Texas at Austin. So what I have done there is I have created a synthetic river bathymetry. So where you don't have any data, you can create a three-dimensional shape of how the river might look like, and you go with that information. And to create that synthetic bathymetry, all you need is some basic information about the channel center line, some approximate width and depth. Then I modified that instead of, so when I published this, a lot of people came to me and said, we have cross sections, we don't want to generate a synthetic bathymetry, but we really like your mesh, so can we create mesh from cross section? So to respond to that, I created bathymetry interpolation tool. So this tool takes your cross sections and creates a very nice mesh, which you can integrate with your DEM or LiDAR. And then you'll see a big gap from 2008 to 2019. So when I was working on this, I did write several proposals, I did write several papers, and many of those got rejected, saying that we don't need all of this, we are going to have this green LiDAR. So then I said, okay, maybe that is the case. And in 2019, we still had all the same issues that I was facing in early 2000. So then we wrote a proposal and then we are here, so it worked. So going from RCMM to Spring, so RCMM used to work for individual reaches, Spring works for entire stream network. So you can actually create a three-dimensional bathymetry for a large network, and we'll talk more about that later when we discuss use cases. So this is the work that was going on at Purdue, beginning at UT Austin, and then some of my colleagues at Iowa, they were also working with river morphology data. So you see Arc River on the left. Some of you are familiar or maybe familiar with Arc Hydro. So Arc Hydro was again created at UT Austin. I was there, and ArcHydro deals with watershed data. It doesn't really specifically deal with river channel or river morphology data. So Mari and Maste, one of the co-PIs on this project, have been working on Arc River for quite some time. It took time to get that paper published. So even though the Arc River, it says 2015, I think he's been working on that since 2007 or 2008. So Arc River is similar to ArcHydro. It provides a standardized structure for storing river-related data, not just physical description, but also hydrodynamic description and data coming from ADCP and so on. Similarly, Ibrahim Demir, another co-PI on the project at Iowa, and also Marian Masti, they have been developing a lot of web platform for sharing and publishing water resources data. So you see two examples here, Iowa DIS and Iowa DOT, and Ibrahim will talk more about this. So we have all this work going on in parallel, and then we said, okay, let's propose a vision. So the vision that we have here is the River Morphology Information System. So we want to create a platform that is interoperable, that is easy to use, and that can provide access to tools and data sets related to river morphology. And we want this to be community-based and community-driven. And this is something that can be used for research and education. So again, just a simple open platform where people can come, get river morphology data, also share river morphology data, share tools, use tools. So again, just community-based framework for river morphology. So we had this vision for quite some time, and then we found an avenue to propose that vision. So this is the NSF Geoinformatics Program solicitation that I think NSF had Geoinformatics program before. I think that was discontinued, and then in 2019, this was the solicitation that came out. So there were 3 tracks: catalytic track, facility track, and sustainability track. And you can see the catalytic track supports pilot geoinformatics development efforts that are intended to serve earth sciences research. And we thought that we have been doing all this work, we have a vision, and I think that fits this catalytic track, and we proposed that to NSF, and we were lucky enough to get that project funded. When we wrote this proposal, this was called River Morphology Data Analysis and Tools, and the acronym that we used was RIMORPHIS. After the project got funded, we learned that there is a tool that exists called RIMORPHIS. It's a proprietary tool. So when we learned that, we spoke with the developer of RIMORPHIS, and then we agreed that we will change our name. And I actually like this new name much better. So RIMORPHIS, something new and unique. So we are calling our project RIMORPHIS now. As I mentioned, this is a collaborative project. So there are 4 institutions involved: Purdue, Iowa, St. Louis University, and UC Boulder. And we started last year, and we will go until July 2023. And this is a catalytic track pilot project, and our hope is that we will be successful in accomplishing our vision, the prototype vision, and hopefully we'll write proposal to go to the next level. So this is our functionality. So what kind of functions that we want to provide through RIMORPHIS? So what you see here is a point. So most agencies, they start with observations, and these observations are collected at a small scale at points. And then we go from points to reach, and then from reach to watershed. But as a user, we are mostly interested in looking at watershed, as a hydrologist at least. So I start with the watershed, then I see what is available within that watershed. So we go from watershed to reach and points. You can see there is a sort of circle here. One the data provider going from point to watershed and user going from watershed to point. So we want to use that framework in such a way that we have a seamless integration of these data sets across different scale through a common identifier. So in terms of functionality, we want to have search capabilities, analyzing capabilities, visualizing capabilities, download, access, upload, archive, and so on. And this is not just for user, but also for data providers. So if somebody is collecting data, they don't have an avenue to publish, hopefully they can do that through RIMORPHIS. This is the conceptual framework, and this is how the features will look. So I go in a watershed, I look for a reach, and that reach will give me information about what's available at that reach. So you can see these are the cross sections. And then at each cross section, there are observations, point observations about sediment, about channel roughness, and hydrodynamic observations, and so on. So these are the features that a user may see when they come to RIMORPHIS for discovery. In order to support all this, we need a robust cyber infrastructure. So we have 5 layers here. So the front layer will serve the user through query and map interface. Then we have database and web service layer. So this is for data storage and interacting with other resources. We have visualization and mapping layer. And then we have modeling layer that will serve the tools and enable that research and application that I mentioned in my earlier slide. Behind all this, there is also going to be a data model. And again, Ibrahim will speak in more detail. So just to give you a short overview, so you can see we have catchment here going on the left. So from catchment, we go to line, center line or river reach. From line, we go to again cross section and points, and then each point you will have data related to sediment, roughness, and so on. These are the tools and resources that we identified when we were writing the proposal, thinking that what these agencies collect and will be useful for us. And these are some of the tools, again, public domain tools that we thought will be useful for us. And we also included some of the tools that we have been developing. So as I mentioned, RCM and Spring. So many of the agencies that you see here on this slide, they are here in this workshop today, and we will hear some of them in a short while. We also propose some use cases. So we have the platform, how can someone use it? So again, I'm just giving you a broad overview here, and we will talk in detail about these use cases after maybe 15-20 minutes after Ibrahim's talk. So we want to have discovery, so somebody can find and download data. We want reach scale analysis, so assembly and visualization of multi-instrument data acquisition. Network scale analysis, so that availability questions, so can we combine data sets from different resources and create something at a larger scale. As I mentioned in the river morphology definition, so we think of this river composition and description that is changing with space and time. So we also have a use case that we look into that. So long-term channel morphology forecasting. This is the project timeline that we proposed. We are in year 1. So this is fall, spring, summer. So we are, depending on where you are, summer may have started for you, but for me, it feels still feel like winter. We had snowfall just 2 weeks ago. So we are in year 1, and you can see this is our workshop that we proposed in summer. So we are a little bit ahead of schedule, but we are also making progress in terms of finding data resources, developing the data model, and creating our interface. So with that, I stop here. I know I ran little 2 minutes over than my allotted time. So if you have any questions, please type them in the chat box and